Business Calculus, Topic 4, Homework Problems number 35 and 36. 35. The weekly sales of Honolulu red oranges is given by Q equals 837 minus 9P. Calculate the price elasticity of the demand when the price is at $31 per orange. Yes, $31 per orange. Okay, first of all, to get elasticity, we need to have the elasticity formula memorized, which is the negative derivative of the demand function times the price divided by the demand function. Okay, first we're going to need to know what is the demand function. So the demand function is going to be 837 minus 9p. The derivative of the demand function will be 0 minus 9, or minus 9. So we'll put those two in there. Okay, so the negative is here, and the derivative of the demand function is negative 9 times price, which is the letter P, and then the demand function, which is 837 minus 9P. Okay, so everything's in here. We're going to simplify this a little bit. Negative times negative will give us positive 9 and 9P. So 9P all over 837 minus 9P. Okay, and from here we're going to finally put the value $31 for the price inside P, or inside E. So let's put $31 in here. And we'll get 9 times $31, 837 minus 9 times $31 again. And let's figure that out here. 9 times 31, and we're going to divide that by the quantity 837 minus 9 times 31, close quantity, and we get 0.5. Okay, well, this is less than 1, so the elasticity is this is inelastic. Now let's take a look at 36. On 36 we have, here it is. The consumer demand equation for tissues is given by Q equals the quantity 97 minus P all squared, and P is the price for each case of tissues, and Q is the demand in weekly sales. First, determine the price elasticity of the demand E when the price is set at $31. Okay, well, we need the equation, so I have it memorized. Negative Q derivative of P times the price divided by Q of P. And so first I need the demand function, which is 97 minus P all squared. Then the derivative, I'll use the chain rule, so this will be 2 times the function here, 97 minus P, now to the first power, make that look like a 1, and then times 97 minus P derivative. Okay, the derivative of 97 minus P will be negative 1. So all this comes out to be, the derivative of Q comes out to be negative 2 and 97 minus P quantity. Alright, now we can put all this in here. So the opposite of P, and then the derivative of Q will be negative 2, parentheses 97 minus P, and then we'll have times, in that parenthesis, times P over the function 97 minus P all squared. Alright, so let's clean this up just a little bit. I'll distribute this negative, we'll get positive, and then 2 distributes. Well, I guess we don't have to distribute the 2. We'll just put everything in the numerator. So 2 and the P, this 2 and this P, and then parentheses 97 minus P. In the denominator we'll have 97 minus P all squared. Now we're going to put the price in there. $31. Okay, so everywhere we see a P, we'll put $31. This is 2 times $31. This will be 97 minus $31. This is going to be 97 minus $31 all squared. Alright, let's put that in. Quantity 2 times 31, and then times the next quantity, 97 minus 31, close quantity, and then close numerator. Divide that all by open parenthesis, 97 minus 31, close parenthesis, and we'll square that. And we get 0.939. So they want us to round this, I think, to 3 places. To the nearest. Okay, they don't tell us. Okay, so we'll use that for elasticity. Part B. At what price should tissues be sold in order to maximize the revenue? Well, since we're looking to maximize the revenue, this is part B. That was part A. The revenue function is price function times demand. So revenue would be P again, and the demand function would be our 97 minus P all squared. Now we need the derivative of the revenue function and then set it equal to 0 so we can find the max. I'm going to use binomial expansion on this one right here before I take a derivative of this. So this is A minus B all squared. So I need A squared, which is 97 squared. So 97 squared, which is 9409, minus 97 times 2, which is 149. So negative 194 P. And that'll be plus P squared. And again, this is negative 2AB, and this represents B squared. And then I'm going to distribute my P across here. So P times P squared will give me P cubed. P times negative 194P is negative 194P squared. And P times the 9409 is 9409P. Okay, time for derivatives. A derivative of R, revenue, will be 3P squared minus, let's see, this will be 8, 18, 1, this will be 3P plus 940. And we'll set all this equal to 0 and solve for our P. Alright, let me see. Yeah, I'm going to use a quadratic formula on this one. So the quadratic formula will say that P is going to equal the opposite of B, which is 388, plus or minus the square root of negative 388 all squared, minus 4 times A, which is 3, and times C, which is 940, all over 2 times A, which is 3. Okay, let's put all that in. Clear? Alright, open parenthesis for the numerator, 388, and then we'll say plus, and then the root will be second function root, open parenthesis. In fact, yeah, let's keep going. Negative 388, close parenthesis, all squared, and then minus 4 times 3 times 940. Yeah, I think that's everything there, and the root. Yeah, I'll close the root, and then we'll divide. Let's see, I did close the root, right? But I didn't close the numerator. Okay, that closes the numerator, and we're going to divide it all by 2 times 3, which is 6. Okay, so we have a price of $126.86. But let's do it now with the negative. So I'm going to recall this problem again, and I'm going to put in a subtraction sign. right there. And now I have a price of $2.47. Okay. Now one of these two will maximize the price. And let's see. My original function is this guy right here, which is a graph that looks like this. And it looks like the left side is going to be the max, whereas the right side is going to be the min. And 2 is on the left side, and 126 will be on the right side. So this is what will minimize the that will maximize our revenue. Now, approximately how many cases of tissue would we demand at that price? Oh, we need to know the quantity. So that's Q, and Q equals 97 minus the price all squared. So Q is going to equal 97 minus the price of $2.47, and we're going to square that. Okay, let's put that in. Quantity 97 minus 2.47, close, and we'll square that. And so we need to order 8935.9. See, we have to round this up to the whole number, so this will be 8936, and that's the quantity of cases that we need to order.